Deep in the Siberian forests, there is a wall made of perfectly cut rectangular stone blocks. We call this place Mount Shoria, and some of these individual slabs weigh over 3,000 tons. To put that into perspective, if you brought in the most capable heavy lifting cranes operating in the world today, they would fail to even budge them off the ground. But while these stones suggest a missing chapter of engineering, our physical evidence of the people inhabiting this region is microscopic. In 2008, inside a remote cave in the same Siberian wilderness, archaeologists pulled a tiny, unassuming human pinky bone from the sediment. Initially assumed to be Neanderthal, sequencing the DNA revealed a genetic code completely missing from the human record. It belonged to a new species called the Denisovans, proving a third type of human walked the earth alongside our ancestors. This creates a profound contradiction. We have a landscape marked by stones defying modern lifting capacity, but a fossil record that consists almost entirely of a single fragment of bone. To understand the potential of these people, we look at their biology. When researchers analyzed a massive skull found in China known as Dragon Man, they found a brain capacity roughly 20% larger than a modern human's. A brain of that density requires an immense amount of calories to run, but it allows for significant cognitive power. The physical size suggests they possessed highly complex pattern recognition and memory processing capabilities that exceed our own neurological architecture. Their physical bodies were built to match that processing power. Genetic mapping indicates they possessed a hyper-resilient immune system capable of surviving extreme plagues, alongside a cellular aging process that moved slowly, allowing for a longer lifespan. We see the legacy of their biological endurance today. At the 14,000-foot elevations of the Tibetan Plateau, modern human populations thrive in thin, freezing air that would make most people severely ill. They survive because of a specific biological trait called the EPAS1 gene. This gene restructures how human blood cells bind to sparse oxygen molecules, and modern Tibetans inherited it directly from the Denisovans tens of thousands of years ago. Denisovan biology was functionally superior to our own. The physical traits they left behind are still keeping people alive in the absolute harshest environments on Earth. Their cognitive advantages translated directly into their physical tools. Buried near that tiny pinky bone, archaeologists uncovered a green chloratolite bracelet dating back 50 to 70,000 years. When material scientists looked closely at the carving, they found a perfectly straight, meticulously polished hole. You cannot create a perfectly symmetrical, smooth interior wall in stone like this without utilizing high-speed rotary drilling. In the exact same sediment layers, researchers unearthed a 50,000-year-old bone needle with a carefully crafted eye. It shows they were utilizing forward planning and advanced tailoring to make precise clothing. These artifacts show a mastery of mechanical fabrication and precision tooling. They were machining jewelry and tailoring garments, while our other human ancestors were still limited to rough animal skins. The discovery of high-speed drilling and precision tailoring suggests these people possessed technical capabilities far beyond what we previously thought possible for the era. It is exactly these specific capabilities that make the megaliths at Mount Shoria so provocative to modern researchers. Across the region in Mongolia, we see similar megalithic structures that serve a highly complex purpose. The massive stones align with astronomical events, capturing the exact moment the sun sets perfectly during the summer and winter solstices. This level of celestial tracking and heavy engineering predates recorded history by a wide margin. It suggests that advanced structural planning began tens of thousands of years earlier than we assumed. Seeing this kind of engineering forces us to ask a difficult question about the monuments we thought we understood. Were the later great empires of the ancient world inventing their own architecture, or were they following the blueprints left behind by the Denisovans? If a species possessed higher intelligence, disease-resistant biology, and precision manufacturing, they should have dominated the planet. So why did they vanish? One theory points to population size. As aggressive waves of Homo sapiens expanded into Asia, our numbers could have triggered a violent territorial push, forcing the Denisovans to retreat into remote caves. But a tribal war doesn't explain the complete erasure of their architectural footprint. The geological record points to a much more immediate culprit, an event known as the Younger Dryas, which struck the Earth roughly 12,800 years ago. This is a segment of an ice core sample extracted from deep within a glacier. By measuring the trapped gases and isotopes inside these layers, scientists can observe the physical evidence of a massive, sudden disruption in global temperatures. On the surface, the effects of the Younger Dryas were apocalyptic. The evidence suggests a period where fire rained from the atmosphere, immediately followed by catastrophic global flooding. Massive walls of water ripped across the continents, resetting the physical map of the world. This sudden environmental wipeout would have buried their cities instantly. Whatever towering stone structures and advanced machinery existed were crushed and sealed under thousands of tons of mud and debris. They were erased so thoroughly that for millennia, our only proof of their existence was a single fragment of a finger bone. It's a reminder of how fragile a species is against the planet's geology, leaving you to wonder exactly how many more forgotten chapters of human history are still waiting under the dirt.